Hello student, welcome to our channel. I am vasanth.nayak from Canara Engineering College. In this session, we will see how to design code for a 4-bit adder using VHDL. So, today's session is about VHDL module for 4-bit full adder. In the diagram you can see here, we have taken single bit 4 numbers of a full adder. We know a full adder is a circuit which adds 3 bits, 3 single bits, that is A, B and carry from the previous stage and provide the output sum and carry out. So a single 4-bit adder looks like this. Such a 4 numbers of 4-bit adders we have cascaded as shown in the diagram here. So 4 single bit full adder is connected as shown in the diagram. So the final output is something like S0, S1, S2 and S3, where S3 is MSB, S0 is LSB. Similarly, input is A0, A1, A2, A3 and B0, B1, B2, B3. So 2 4 bits A0, A1, A2, A3, B0, B1, B2 and B3. This is the function of 4-bit full adder. Now we will see, before moving to 4-bit full adder, we will see the entity and architecture of single bit full adder. So as I said, full adder, the block diagram of full adder you can see here, which adds X, Y and C in and provides output C out and sum. So in VHDL code, main declaration is entity, other than that architecture. So entity declaration is something like this, entity followed by name, that is entity is the keyword. Entity port are the keywords, followed by the name is nothing but user defined word. So full adder we use the word full adder is followed by 4 declaration, that is here X, Y, C in are input type, data type bit. So in the last example we have used data type standard underscore logic, that is standard logic, but bit is a different data type compared to standard logic. Bit has got only 2 values, 0 and 1, but standard logic contains different values. Similarly, we have Cout and sum of output type and data type is bit. So entity should end with the end followed by entity name. Similarly, declaration of architecture, here architecture statement, architecture name for the architecture is given here. It is user defined name. This is the user defined name of this architecture belongs to entity full adder. So we have to write the our expression between begin and end statement. Here begin and end statement we see here sum and carry Cout expression. So I have already explained this one in my earlier session. So this is about single bit single bit full adder. Now we will see 4-bit full adder. Now in 4-bit full adder, we declare architecture in the structural way of modeling. You can see there are different way of modeling. One is called as a structural way of modeling. Second one is a data flow modeling. Third one is a behavioral modeling, right? So normally, as I told in my previous session, structural and data flow modelings are used for small design. So and behavioral modeling used for larger design. That is, by using behavioral modeling, we will design big circuit with the help of structural and data flow modeling. So now here you can see in the structural modeling, what we do is we define structures. Like here, structure is nothing but a component of a full adder. So we have already designed full adder, and we are calling and we are declaring that component here. So you have to remember one thing here. Component should be declared before begin statement. You will see this one. Before that, once again you have to declare here entity name, and followed by port A and B and of type in, and it is a type of a bit vector. Bit vector means it can take like number of bits. Like in this case, 3 down to 0 means it makes use of bit 0, 1, 2, 3. All these are type of bit vector. Similarly, yes, output is also, we need as output is as I told, our output is S0, S1, S2, S3. So you can declare that one in this way. S of output type and of data type is bit vector. And you can specify bit of a vector, or it's the array of 0 to 3. So the way of the syntax is 3 down to 0. Similarly, C0 is the output of bit it's a single port. C in is also single port of input, and this is output. So an entity should end with the end entity followed by the name. Now in the case of architecture, structure, because we are it is a user defined word, we are defining here the components in the way of structure. So it is called as structural modeling of ADDER 4. So ADDER 4 is, first you have to declare the component. Component declaration is something like this: component and end component, and here component name should be the name of the smaller design. In our case, we have already designed full adder. The name of that full adder is full adder entity. So in that full adder entity, we declared this one. We have to exactly copy that lines here. Other than that, here internal signals are represented by signal. So internal signals are represented by signal C of bit vector 3 down to 1. After that, you have to call the components by using port map. So while calling port map, I will use the label full adder 0, full adder 1, full adder 2, full adder 3, colon, full adder, port map A0, B0, C1, CI, C1, S0. So similarly, FA1, FA2, FA3, something like this. Here, this one will be mapped to this one. This one will be mapped to this one. This one will be mapped to this one. And this one will be mapped to this one. This one will be mapped to this one by using port map command. So the main goal of this session is we will tell you how to design bigger design by using smaller design. Here, smaller design is nothing but our this one full adder. We have already designed that one full adder. Then we are calling that full adder 4 times to design 4-bit full adder. Now we will see this one in Xilinx software, how it works. So student, click on Xilinx software. Once you install Xilinx software, you will see the icon, and double tap on the icon. It will open the project navigator. In the project navigator, if any project is open, then close the project. Otherwise, click on left top corner, that is the file option. Close the project, and once again click on the left top corner, create new project. So project wizard starts. In the project wizard, give the name for the project. You can give any name. So but while using special character, you can use only underscore. So here I will give the project name, that is project name, that is 4-bit adder, 4-bit adder. So let me give the project name 4-bit full adder, and select the directory project location. Click on next. So here we are giving the information about the hardware to the software, that is the FPGA in our case is Spartan 3, and device according to the manufacturer is this one, and package is this one, and we are using the language VHDL to program the FPGA. So click on next. Finish. So you can see the package now here. The package has been created, and this is our project name. Our hardware chip has been created here. Our hardware chip has been created, and we are going to program this hardware chip by means of VHDL. For that we need to add the source file. But the main goal of this design is first we are using smaller design. That is first we design the component, that is a full adder. So for that right click this one, our chip, FPGA chip. Right click, add new source. Here we will use VHDL module, the option to write the program, and I will give the name here FULLADDER full adder 1. This is the name you have to use you have to use the same name in the bigger design also. When you are calling the component full adder 1, I will give the name full adder 1. You can give any name, but there is some restriction that you cannot use some special character except underscore. And you can set the directory. Click on next. Here you have to give mention the input and output. So let me mention the input and output here. That is, input is x, y, comma C in is the input, and our output is Cout followed by sum, and this is the output and this is the input. This is the output and this is the input. Fine. So now click on next one. Doing so, entity is created for the full adder, 1-bit full adder. Entity is created. Here you can see the entity is created here. On the left corner you can see this is the entity file. So double click on that one. When you double click on that one, it will open the code window. So many code has been written by the Xilinx software for us. So we can delete the unnecessary code. So you can delete the unnecessary code. These are the commands not required. And this is the library section declaration, as I told in my previous video. So this library contains all the necessary functions. So this code once again not declare. This is the commands not required. So we have now entity and architecture. So entity, we have in entity already 4 declaration has been made. You can see here X and Y, C in are the input port of standard logic. Output Cout and sum and Cout and comma sum are the output port of standard logic. You can use other type also bit in case required. Other than that, we have architectural declaration here. So in architecture declaration, what we have to do is we have to write the expression. So let's write the expression for this one first. So I will copy the expression from here itself. This statement you have to copy between begin and this. So now the code is ready for full bit adder. The full bit adder, now we have designed the component full bit adder, let us say a full adder of single bit. So now we have to synthesize the code to check whether any semantic error is there. So for that, click on synthesize XST, double click on that one. While when you double click on that, doing so it will ask for to save the code. Click on S. Our synthesize process says it is failed. So in order to check where is the error, and number of errors is 1, number of errors are 1. So you can see here error line, and it says like line number 15. unexpected identifier, that is 15 line. So this is the unexpected identifier. You can see begin and sum has taken a single word. So if you click this one, it will take you to that line. It will take you to that line and you can easily detect the line. So here I will enter. Now once again I will click on synthesize and rerun. I will click on synthesize and click on rerun, and it will once again pop up to save the code. Yes. Now you can see so synthesize is completed successfully, and you will get here green mark. You will get here green tick mark. That means our code is ready to generate the hardware. Now this is the first part of the design is completed. Now we have to design second part, that is ADDER 4. We have to design this one, ADDER 4. In that we have to declare the component and we have to call the component. So let me take you to once again to the same design. Right click our this one chip, hardware chip, and click on new source. Here select the module, VHDL module, and here select ADDER 4. Here select, give the file name ADDER 4. Next, here you need to mention the port name. So the port name in our case is so let me take you to the once again to the blackboard. So you can see the port name is A and B are the port of bit vector. That means it will take 4 bits, 0 to 3. So how to mention that in this case? So A and B, A comma B, A and B of type in, and you have to check this option bus, and here LSB is 0 and MSB is 3. You have to mention this one 3. You have to mention 0 and 3. This is the way you mention, this is the way you mention 3 down to 0. Similarly, S is the output. S is the output. Output is also 4 bit, 0 to 3. So select 0 and here it is 3. Other than that, we have carry in and carry out in our design. We have carry in and carry out. So you have to take C in, that is the input type, and we have C out, and that is the output type. You have to mention all these things, then click on next, finish. Here you can see, as I said, these are the some of the informations are commented here. So we don't want that one, you can delete it. So this is a library section. Other than that, we don't want this information also, you can delete it. So now you can see now here. So entity ADDER 4 is the circuit. Entity ADDER 4 is the user defined word. You can see the difference between user defined word and our keyword. Keyword resembles in blue color, and user defined word is in black color. So User defined word is adder 4 is 4 declaration A and B of type in and standard logic underscore vector. Similarly, S is the output standard logic underscore vector. Similarly, C in standard logic, C0 is the standard logic. So now we will complete the architectural part by calling the component. Now student, you can see here I have created once again main design. So I created the main design here with the small changes, that is this time you have taken bit vector rather than standard logic vector. Standard logic vector has got multiple values, but bit vector has got only only two values, 0 or 1. So here you can see entity with the name adder 4 is created. Other than that, you have declared the architecture, and user defined word is the structural way of modeling of adder 4. This entity is and we have declared the component also. In the component, you have to give the name of the smaller design or the name of the component that you have designed earlier. In our case, it is a full adder 1. Same thing you have to copy here. I mean 4 declaration and all, it should match exactly to that file. After that, we have to call that full adder 4 times. For that, full adder 1, full adder 1, full adder 1, full adder 1, 4 lines you can see by using port map command, and that will map all these different variables to these variables here. So same, each line can be labeled as FA0, FA0, FA1, FA2, FA3, etc. and structure. This is called a structural way of modeling. Once this is done, you have to synthesize. So when you rerun synthesize, you will see here so synthesize completed successfully with the green tick mark. That means our code is ready for hardware generation. So now here, if you click this one, so this is our chip. In this one, you can see this is the adder 4 entity, and that call 4 times our component in order to generate a 4-bit full adder. Once this is done, we will proceed to now test bench, and we can see the output in test bench. So related to test bench, I have already told you how to give the input. In the same way, you have to give the input and you have to check the value for you have to check the value either for 2 combination or 3 combinations. In this way, you can implement this one 4-bit full adder by using full adder. This is called as a structural way of modeling. Thank you.